Yeah, sorry guys, I was on mute. Uh, Anyways, yeah. Good evening, everyone. Good evening. Good evening. Good evening. Good evening, Vinith. Good evening, Sneha. Good evening. Good evening. All right. A very warm welcome to you, everyone of you watching the live session. Right. This is day two of the C++ Bootcamp. Hmm. Yesterday, so who'll tell me what all did we cover yesterday? Just the topic names. I just want the topic names. What all did we cover yesterday? Hi, good evening, Tarun. Good evening, Vaibhav. Good evening, good evening. So, who will tell me what all did we cover yesterday? Just the main topics. I don't want everything in detail. Just the main topics of what things we covered. Okay, we covered if else. I think we covered operators, right? We covered data types. We covered variables. We covered the installation part. Achha, by the way, I hope everyone now has at least any of the compilers or any of the IDs installed on their machines, right? Be it should not be necessarily VS Code. It can be anything, but you should have at least one local compiler apart from the online one as well. I hope everyone has. If you're having VS Code, I would suggest having VS Code. But if you're having VS Code, I hope everyone has MujiW and everyone has set up the local. Everyone has set up the path as well, right? From the environment variables, right? Okay. So starting with today's session, right? So we'll quickly cover loops first, right? So we'll quickly cover loops, right? And then we'll start with the functions part. After that, we'll start with functions. Okay. So talking about loops, I'll just give you a situation, right? I'll start. Okay. I'll just start with the question first of all. My question is: let's suppose I want to print numbers from 1 to 50. So what would be my first initial thought that would come to my mind? My question is, I want to print numbers from 1 to 50. Hmm? What is the first impression that I get if I'm a very naive programmer? Let's suppose I have no idea about loops. I have no idea about loops. What will I do? Obviously, I'll write C out 1, right? Then I'll write C out 2. Then I'll write C out 3 till 50 times. A bit hectic, right? A bit hectic. Not neat, not legible, too lengthy. What if instead of 500, my let's suppose my manager tells me, hey Ritik, you don't want to print it till 50. Now you wanted to print it till 500 or let's suppose 5,000. So how will you do that? Anyone? So will you go ahead and write 1 to 5,000 line by line or 50,000 line by line? No, right? This will not be the case. So that's where loops come into picture, right? That's where loops come into picture. Loops help you to repeat a specific part of the instructions till the condition you give it to, right? So you just have to you just have to tell your machine that, hey, I'm repeating the same task again and again. So why not you do one thing? Just provide me a loop and just loop it around till the ending condition. Ending condition is something that I have to provide. Okay. Now, talking about loops, there are majorly two categories of loops in C++, right? One is called as the pre-computation, one as the post-computation. In pre-computation, we have something called as a do-while loop. Right? This is not used much, right? Not useful actually. I would say we can use it if you want to, but uh, we don't prefer using do-while. In post, we have two types of loops. One is the while loop, and the other is the for loop, right? And these two loops are most widely used, right? Yeah, Mono. So see, again I told, right, we can use any type of loop we want to, right? Obviously that is the case, but we do prefer using while and for, because this while loop, actually serves the purpose of both while loop and do while loop, but not vice versa. So that is why we don't, actually it's not that useful. Yeah. Sir, I wanted to ask yesterday, is there a MinGW for Mac? Yes, yes, Kellen, there is. And there, in fact, I told you yesterday as well. We went to the MinGW website. There were three options, right? For Macintosh, for Linux, and for Windows. You have three options. You can download it from their website as well. We have Mac there, right? Okay. So now talking about the syntax, right? Very most important thing. We got to know that okay, we have a while loop, we have for loop, but how do we use it? Very simple, right? So I'll just quickly show you a demo. What I'll do here is I'll come to my VS Code again. Let me just increase the font a bit. Let me make a new. Okay. Let me make a new file. I'll say day2.cpp. And first we'll be covering, let's suppose, for loop. Okay. Again, my condition is same, that I have to uh, let's suppose print numbers from 1 to 10 or 1 to 100, right? So first of all, I'll just include the header files. Okay. So actually we have a shortcut for including the header file, right? That is IO. But for that you need an extension. So just come to the extensions. Just come to the extensions tab on the VS Code and just download. Just download this one. C plus, no, not this. Yeah, this is the extension that gives you the boilerplate. It is C plus plus boiler code. So if you just download it and you just press or type IO, it will give you the basically the whole boilerplate. You don't have to type it again and again, right? So I have it. If you want, you can also download that. Right? So yeah, I'm just increasing the font size, right? Okay. Now again, want to print numbers from one to 10, right? So just observe the syntax here. I'll write for int I equals to 1, then a semicolon, I less than, okay, till where do I need to print it? Let's suppose I want to print it till 100, I less than equal to 100, and on each iteration I want to increase the value of I. I'll write I equals to I plus 1, or you can write I plus plus. I plus plus is same as I equals to I plus 1, right? I'll just write it. I plus plus is same as I equals to I plus 1. Okay. Now, what do I need to do? I need to print numbers. So I'll do cout I. And after each line, after each number, I want to move to the next line. So I'll write ended. Okay. So what is this? See, just take a. I'll just take a screenshot and let me explain it to you in this. Okay. So this is the syntax, right? You have to write for if you're using a for loop. Now this part here is the initialization, right? You initialize it, right? And this is the terminating condition. I told you, right? If you are having a loop, you need to tell your machine that, okay, hey, I need to stop at this point, right? This is the terminating condition, right? And this you see, it's an increment operator. So on each iteration, what will happen is it will increase the value of I by 1. Now there are two types of increment operators. One is pre-increment, that is plus plus I. One is post increment, that is I plus plus, right? What is the difference between the two? See, let's suppose if I have a variable int I equals to int I equals to 1, right? And I do C out plus plus I. This is one way. And the second situation is I do C out I plus plus. Now interestingly, this will give me the result as 1. Oh, sorry, not 1, 2. Let me get the eraser. Yeah, this will give me the result as 2, but this line, it will give me the result as 1. Why 1? Because it is a post increment. It will increase after you are done with that execution of the line, right? So this is pre and this is post. As the name suggests, right? If you're having plus plus before, it will first add, then print, or then execute. If you're having I plus plus, it will first execute I, then increase. So in this case also, the output will be 1. However, the value of I will be 2. It will be increased later, not at that current step. Yeah, got it? Piyush says, what if plus plus I and then I plus plus. So okay, I hope I'm audible now. Yeah, I think there was some network issue. Yeah. Okay. Right. So exactly. Let me just come again. So this part, right? So as I was saying, yeah. All right. Hmm. Right. So I hope. Okay. I was explaining this, and I think some student had asked me this question. What will happen if I do plus plus I, then this I plus plus, right? So again, it will first pre-increment, right? Let's suppose if the initial value of I is 1, it will pre-increment. It will print the value of I. After printing, it will increase the value of I. So in printing, you'll get 2 because of this pre-increment. But the actual value of after printing, it will be 3, right? As simple as that. Okay. Okay. So now this is the syntax, and after this we have the condition, right? This is the condition. So whatever we want to print or whatever operations we want to perform, we generally do that. Right? And let's try to run this now. I'll first clear the screen. Okay. Now I'll run it. Right. Okay. So as you can see, in just two, or I would say three lines, right? I got the numbers printed from 1 to 100. How cool is that? Instead of writing see out each and every time, I'm getting 1 to 100, right? As simple as that, right? The second type of loop is again a very similar loop, right? Does the same purpose, and this one is called a while loop. Now, while loop is the syntax, it is a syntactical difference, right? The purpose is the same. And what is that? You first write while, then you write the condition here. Here comes your condition, right? And then here you write the executable lines. Whatever you want to execute, functions, you want to write some logic, you want to write some print statements, you do that. So let's see the demo first. So I'll just comment it out. I'll say int I equals to, let's suppose, 1 only. Now comes the while loop and the condition. The condition is I less than equal to 100. See out I, and I'll say end it. Acha. There's one small mistake in this code, right? There's one small mistake that I have purposely done in this code, and let's see who can figure this out in the chat box. What is wrong in this code? Anyone? Yeah. What is wrong here? Okay. I is not changing. I plus plus. Still, I've not got the infinite loop, right? Okay, I have an answer from. Okay, I think you guys are there. Yes. So what is happening here is I am looping it around, right? But do you think that the value of I will increase? No, right? So as a result, it will go into infinite loop because I'll print I. Initially I is 1, right? I'll print I. Okay. Again, I'll again go to the loop. I'll check the condition. Is 1 less than 100? Yes. I'll again print I. I'll again go to 1. I'll again print I. This is an infinite loop because I'm not increasing the value of I. If I do I plus plus, this time it will not go into infinite loop because I'm increasing the value, increasing the counter of I. Right? So I run this and see I get the exact same output which I was getting using a for loop. Right? Chalo. Awesome. Clear? Is the difference clear between a while loop and a for loop? Anyone? Any doubts? Will add increment operator? Yes, sure. Yes. Okay. Yes. Increment operator is not used. Right. Chalo. Now let's just move ahead, right? Okay. The next topic that we want to cover now are functions. Okay. Just give me a second. Yeah. Let's see what are functions. Okay. Now, I would again like to start with a question. Let's suppose you have a situation. Let's suppose you're designing a calculator and you want to write a logic of adding two numbers, right? Basically just a plus operator, nothing else. Right? Now what will happen here is, see, the question is I want to add two numbers, and these two numbers can be different, right? I'm a user, I'm using a calculator, I can write multiple different numbers to add. It's my wish. So what is the first approach that comes to your mind? Let's suppose you don't know what functions are. You don't know actually presently. So what will you do? as we did yesterday, right? You'll just make two variables, int I equals to, let's suppose 10, int j equals to, let's suppose 20, and you want to add these, so you'll get the result as 30. But the next time I as a user don't want to enter 10 and 20. Let's suppose I want to calculate the sum for 100 and 200. So will you write the whole logic again? I mean, will you replace the whole numbers again? What do you think? And let's suppose this time I don't want to calculate the sum. Let's suppose I want to calculate the difference. So will you write the whole logic again for difference? Again and again? No, right? So that's where functions come into picture. Functions help us to repeat a specific block of code, right? What are functions? These are a block of code. Here is some code written that can be executed multiple times. Don't get it confused by while loop. While loop is different. For loop is a block. It is a block of code which can be repeated again and again in the program. Let's suppose this is a code for adding two numbers, and I want to add two numbers 1,000 times. So what do I have to just do? Just call this function 1,000 times. Just call this function 1,000 times, or maybe 10,000 times, to compute the sum. Right? Now, how do we declare functions? Right? How do we declare functions? So, in C++, you first have to write the data type. Right? Then the function name, and then we'll start your function. Right? Let me do it for you to see it practically. So I'll comment this out. Okay. Now I'll make a function here. I'll say, let's suppose I'll make a void function. Let's suppose I don't want to return anything. I just want to print something. Void. And add underscore numbers. And here I just want to see out. Let me take two numbers here. Int I and int j. Now, what I want to do here is, I just want to print the sum of these numbers, right? Now, how can I do it? Again, we did that yesterday. I'll make a new variable. I'll say int sum equals to I plus j. Right? Now, I'll just see out the value of sum. And let me also print ended. Right? Okay. This was the declaration part. I'll explain you what these terms are called, right? Parameters, arguments, different between the two. But let me just write it for you once. This is the declaration part. Okay. And this is the invocation part. How do you invoke a function? You write add underscore numbers, and you have to pass two numbers. Right? Let's suppose I'm passing the sum of 10 and 20. Okay. Now let me just first show you the result, then we'll see the step-by-step explanation of how it's actually working. So I'll print it, and I'm getting 30. The next time, let's suppose a different user comes up. He says that, okay, I don't want to print number up the sum of 10 and 20. I want to print the number sum for 100 and 200. You just have to make changes here in this part. That's it. Because the logic you've already written, right? Now you change the numbers, you run it again, and this time I'll write 100 and 200. Okay, and just save it as well. Let me just clear the screen and let me run it again. See, now we are getting 300. That means that we have just written a function once, and we can call it multiple times with different numbers. That's how actually a calculator works, right? You calculator is not already com- it doesn't follow pre-computation. Like you given the numbers at runtime, it calculates the numbers on runtime. Okay, let me just take a snapshot of it and let me explain it to you. Okay, now this here you see, these are called, who will tell me what is the difference between these two values? What are these called? Anyone? I think I already have an answer in the chat box. Okay, I'll tell you. These are called as exactly said by Raul and Yash, parameters. And this is called as an argument, right? This is a very, I would say, an important interview question. Interviews generally trick you by asking you the difference between parameters and arguments. So don't get confused. Parameters is something that we use when you declare a function, and arguments we use when we invoke a function. Invoke. Okay, right? So parameters on declaration and arguments on invocation. Exactly. Now I hope everyone, no one of the audience watching here in the chat box will, in the live session, will not forget the difference between an argument and a parameter. So argument while invocation, and parameters in declaration part, right? Okay. So and this is the return. This is the return type. Basically, void. As I told you, void means empty or nothing. That means this function is not expected to return anything. If I see, if let's suppose I want it to return something, so how can I modify my code? I'll say that, hey, just do one thing, just make it int. Let's suppose I want to return an integer value, int, right? And what I'll do, I'll calculate the sum and return the sum, because obviously the sum will be an integer value, right? I hope you guys agree with me on this part. The sum will always be an integer. So I'll say, or it can be a decimal if we want to, but if we, let's suppose if we want the sum of 5.5 plus 4.9, it will be 10.9. So it will give the result to round off as 10. It will only take the integer value, right? Now, instead of printing the sum, I'll say return. Hey, don't print me the sum, just return me the sum here. And in the invocation part, I'll say whatever sum you're returning, I'll catch it here. Int received sum equals to add numbers between 1 to 100. And here I'll print the value of uh, receive sum. Again, I guess it's showing some error. Let's see what that is. It says cannot overload. Uh, returns. This should not be an error. Return. It says a value of type void cannot be initialized empty. No, it's not void. It's integer, right? Int sum equals to this, and we're returning an integer. Return sum. Yeah, we are returning sum. We are returning. Cannot overload function distinguish by return type alone. Hmm. Int add numbers. Let me make a new function. I think it's getting confused. I'll say int add number. It will take in two numbers, int I and int j. I'll say int sum equals to I plus j, and I'll say return sum. And here let me rewrite it. I'll say int received sum equals to add underscore number, and I'll give two numbers, 100 and 200. Okay. Did we do something different? I'm not sure. Okay. Anyways, okay. Now so in this, let's try to see what the result is, and it is giving the result as 300, right? So what changes we have done to the code? Instead of void return type, right, we are now having an integer return type. That means it is expected to return an integer. Sum will always be an integer, and we are returning an integer. Remember, if we are using any data type, any return type apart from void, you have to always have a return keyword, because if you will not have any return keyword, the function will not return anything. It's good for nothing, actually. If you want, you can print. See, I can also print the sum here. I can also print the sum. I'll get the correct answer. But if you are printing it here only, then what is the need for having an in data type? You can always have it void, right? You can always have a void there if you don't want to return anything. Similarly, you can have a character return type, right? It's up to you. It's up to your needs, what all things you want, and that's it. Okay, I hope I'm clear with this part. Okay, now I'll introduce to a very interesting topic, and that is called as function overloading. Function overloading, and this is a very, 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 very important topic, right? So, what is function overloading? Let's suppose I have two options, right? I'm given two options, that either the user can enter two numbers, right? Either the user can enter three numbers. But I'm pretty much sure that both in both the cases, I'll have to perform the addition. This is a given condition to me, right? That means the function name has to be same because I'm adding it, right? Function name should be same. But how will I distinguish between the two functions? So what I mean is, see, let's suppose this time I'm given a condition that, hey, my manager comes to me and says me that, hey, Ritik, we might have users who might want to print the sum of three numbers maybe. So in this case, what should I do? I'll make the same function name, but this time it will be carrying three numbers. So what will I do? I'll just quickly copy this function only and introduce a new variable, because I want to calculate the sum of three numbers, int I, j, and k. And sum will consist of three numbers, I, j, and k. Let me comment this. And this time, if I want int receive sum 2 equals to, let's suppose I want to calculate number of the sum of three numbers this time. I'll say add underscore number and pass three numbers. I'll pass 100, I'll pass 200, I'll pass 300. And this time, let's see the output. Do we get both the functions involved, or will it give some error or something like that? So I'll quickly clear my screen and run the code again. So see, it is giving the sum as 300. Any reasons why? One reason is because I've not I've not printed the sum, right? So I'll say cout receive sum 2. I'll again clear the console out and will again print it. Okay. Now this time, see, we get 300 and we get 600. Obviously, it's coming the same line because we haven't moved it to the next line. So I'll just write endl here so that it moves to the next line. And now I'll again print that. See, this time, see, my function, both the function names are actually similar, add number and add number. But these two functions are performing are acting different, and it is behaving different based on the inputs that I passed to it. If I'm passing two numbers, it is calling the above function, right? This function. If I'm passing three numbers, it is calling the second function. Both the functions are same by name. You can see, you can compare the names, add number and add number on line number 6 and line number 11. But it is acting different on how we're passing the function, or how we're passing the input, how we're passing the arguments to it, right? And that is nothing but this concept is called as function overloading, right? This concept is called as function overloading. As simple as that. It cannot be simple. It cannot be simpler than this, right? So functions having same name but performing differently based on the different arguments you pass to it. Is this clear? Is this clear, everyone? Function overloading. Understood, right? Awesome. Any doubts? Any doubts? Anyone? Okay, awesome. Now, with functions, right, there comes a very important concept called as memory management. Called as memory management, right? So in short, there are two types of memories that we have, right, in programming languages. One is the stack memory. One is the heap memory, right? Now, stack, stack. Okay. Now, any variables you declare in runtime, let's suppose you declare int I, you declare int j, you declare int l, those all will be a part of the static memory or stack memory, not static, stack memory. So once you declare int I, because as I told you, right, it's a variable, that means it is a container, that means it will occupy some space, right? As soon as you declare int I, it will get stored into the stack memory. You call int j, it will get stored into the stack memory. You call int l, it will be stored into the stack memory, right? And it will be there till the execution of the program. So you have this sum variable, right? This sum variable will be accessible only from line number 6 to 10. Why? Because it is in the scope. It is in the scope. These two brackets are scope of that function, right? So stack memory is nothing. It is just a memory that is used to store local variables in your program, like any variable. It can be an array, although we don't know what array is for the time being, but any variable you declare, right? Any operations you perform, any sum you calculate. Let's suppose you do int sum equals to I plus j. So obviously this sum variable which has a sum of I plus j, this will also get into the stack memory, right? Acha. Now one question: what happens, or what if the stack memory gets full? Because obviously, if we are using a memory, we always have a limitation of the size, right? The size could be a problem. Let's suppose you write a program on day one, which is of 1,000 lines. On day two, you write a program which is of 500 lines. So, what do you think? What do you think will happen to the size? Right. So, I'll tell you. There in C++, there is something called as automatic garbage collector. Automatic garbage collector. Now, what is this? According to this, what happens is, see, if you are declaring something from here to here, let's suppose you have declared int I, you have declared int j, you have declared int k, and all these are up in your memory, I, j, and k. Now, as soon as your program ends, it automatically discards all the value from your stack. Vanished. As soon as you finish the program, you've reached the end of your program, it gets vanished. Over. Empty. As simple as that, right? So, in short, you can say yes, it is a temporary memory with automatic garbage collection. With automatic garbage collection, right? This is stack memory. Now, we have something called as the heap memory as well, right? Now, if we want to use a heap memory, right? One disadvantage of using a heap memory is that it does not have auto garbage collection. No auto garbage collection. This means that we have to explicitly delete the variables. Interesting, right? We have to explicitly delete the variables. I'll show an example of both stack memory as well as a heap memory. So let me come to VS Code. Let me comment these two functions. And let's come here. Okay. Now, I have a variable int I equals to 10, int j equals to 20, right? So these variables, as I told you, by default, they get into the stack memory. They start getting piled up, right? Now, if I want to use a heap memory, I have to explicitly tell it by using a new operator. A new we have something called as a new keyword. Just give me a second. So we have something called as the new keyword, right? So just give me a second. I think we are lagging something. So we have something called as the new keyword, right? Now, how does this work? See, before that, let me explain you another concept, and this is called as pointers. Right? Before coming to that, because heap memory, if you're using heap memory, we have to create a new pointer. Okay. Now, pointer, or I would say pointers, are variables which store the addresses, which store the address of another variables. Interesting, right? How can a variable store some address, right? So if I have an integer I, int I, it goes into the stack memory, right? As I told you, if you want to fetch the value of I, how will it do that? So each and every variable that you declare in C++, it has a memory location. It has a memory location. So this I, let's suppose, has a memory location. Let's suppose 101FXH. It is in hexadecimal. It is in hexadecimal decimal in most of the times, but it has a memory location. So if you want to store the address of any variable, in that case you use something called as the pointers. I'll show you an example. So what I'll do here is I'll create a new pointer, and that too dynamically. I'll say int variable equals to, now how do you create a heap memory? By using a keyword called as new int, right? When you write this keyword, it automatically assigns it to a heap memory, right? Now I'll say star var. What do? You store the value of I, right? So what is it doing now? It is storing the value or the memory address of I. What I'll do here is, now I'll see out the value of var. I'll write enter. After that, I'll try to print the value of I, right? And we also have something called as address, right? We represent it by using this symbol and percent. This means that it is a dereference variable. If I see, if I do int j, or I'll say int r equals to the address of j, right? So this keyword, wait, let me write pointer here. So this keyword, what is it doing is, it is storing the address of this variable, right? So that's how it works. Now let me just print two values. I'm printing the value of var, and also I'm printing the value of I, right? Okay. Now I'll call the function. See, now do you see a random number here? Any idea what is this? Anyone? What is this thing called? And it is coming from line number 40. Just a hint, right? It is the address. It is the memory address. Exactly, right? Exactly said by Manisha, Tanu, and Aman. It is the address of I, right? It is the address of I, right? Let me start one thing as well. Let me try to print the address of I. anyways. Right? And as I told you, this value, right, it does not have any automatic garbage collector. So as a result, we have to explicitly delete it. So how do we delete it? We use a keyword called as delete and delete var. This is how we delete it. Because again, as I told you, it does not have any automatic garbage collector. That's how we have to explicitly delete it. Right? So I hope this new keyword, this delete keyword is clear to you. A new keyword is used to assign any variable into the heap memory, and as heap memory does not have its own automatic garbage collector, you have to explicitly use delete keyword to delete it. But in stack memory, there's nothing, there's no concept of delete because it has an automatic garbage collector, and that is the sole difference between a stack memory and a heap memory. Clear to everyone? The difference between stack and heap, is it clear? Yes or no in the chat box? Quick. Clear? Yes or no? So, Parvesh, see, pointers are nothing. Pointers are variables. It is just like any other variable that stores the address of some variable. So this pointer is storing the address of I. That's it. Because if you try to store the address in some other in a normal integer variable, it will not store. Right? So let's suppose I do int I equals to the address of, let's suppose, j. Right? It will not store because it does not have the capacity to store an address. But here, if I do a pointer here, then it will store, because a pointer is only designed to store the address. Right? Chalo. So now let's move to arrays. Right? Very interesting part of it. Arrays. I hope arrays. Now, interestingly, let's suppose if you want to store numbers in a continuous format. So what happens initially? Let's suppose if I have an integer I have an integer j, I have an integer k. So what happens in this case is it gets assigned a random memory address, 1010xfc. Let's suppose this has 110abn. As you can see, this is a very random address, right? So arrays are, it is a data structure. A data structure is a structure that is used to store values which are continuous in nature. Right? So this, let's suppose it has a value of 1, it has 2, it has 3, it has 4. So this whole structure is treated as a single entity which has multiple indexes. These specific boxes are called as indexes, and these are called as values. So, and remember, in arrays, the indexing starts from 0. So that means if I have to give it indexes, this will be index number 0, this will be index number 1, index number 2, and index number 3. So if I say what is present at index number 2, you'll not say 2, you'll say 3, because it's the counting here starts from 0. Yes. Right? If you want to store any value which is continuous in nature, you have to use arrays. Right? Acha. Let's come to the syntax. How do you declare an array? So for that, we have a syntax. Right? We'll say int. Now int specifies that what values you want to store in an array. It can be a character array, it can be an integer array, it can be a boolean array. Right? That's up to you. I'm taking integer for the demonstration purpose. Int ARR, you can give it any name. I'm giving it ARR. Now you have to specify the size. Let's suppose I want to have a size of 4 and provide. So if it has a size of 4, that means how many indexes? That means 3 indexes, right? Because indexing starts from 0. That means 0, 1, 2, 3. 3 indexes. I'll write 3 numbers: 1, 2, 3, and 4. Right? Acha. Now I want to print the numbers. Let's suppose I want to print the value present at the second index. So how will I do that? I'll do it like cout ARR and the value present at the second index if I want to print the third value. So second index. And let's suppose what do we get? See, we get 3. Why? Because 3 is present at the second index. If I write third index, I'll get 4. Right? Acha. Now who will tell me, let's suppose I want to print all of the values all together. What can we use here? I don't want to print one by one. I want to print all the values in one go. How can we do that? Anyone? We just did the concept. I don't want to print the size. Exactly said by Tanu and Anvi and Avni. Right? We'll use a loop. So what I'll do here is I'll write for int I equals to 0 because indexing starts from 0, right? I less than, what is the size here? The size here is 4. So I'll write 5. That means 0, 1, 2, or 4. Because indexing starts from 0, so 0, 1, 2, 3. I'll only need to go till 3. And I plus plus. I'll say, just do one thing, just print me the value present at the ARR of ith index and present ended. Right? And now if I try to print it, see, I'll get all the values one by one. That is 1, 2, 3, and 4. Right? That is 1, 2, 3, and 4. Got it? Is the concept of arrays clear? Anyone? Any doubts? Sir, how to pass? Acha, see, yeah, it's simple. So let's suppose I have a function. Let me use this function only. I'll write int or I'll write void fn. Okay, and here I'll pass this to fn. So I'll say fn, just pass this ARR. Right? And yeah, so in this I'll call the function. It is an integer type of array, and I'll say cout ARR of, let's suppose, second index. That's how we do it. Right? So what do? You just have an array. It's just like passing any other variable, right? You have an array, you pass it to a function, you come to the function and you print. So if I try to show you, let me comment this part out and let me run the code. So as you see, we get 3 here. We are not printing anything here. We are printing it in the function fn. Right? That means we are able to pass the array into a function which can be used later on. All right. So let's wrap it up here. Right? In the next class, we can continue from strings and multi-dimensional arrays, and obviously we'll be starting with the oops in the next class. Right? I hope all the concepts done today, right, starting from functions to loops to arrays to pointers is clear to you, and especially the difference between argument and parameters. And the next difference was between stack memory and the heap memory. I hope that all is clear to you, right? It's a request to, if you can revise the topics before coming to the class, so that it gets easier for you to understand things. Right? So that's all for today, and we'll meet each other tomorrow, right? Good night, everyone. Take care. Bye.